Okay, started.
Yeah, first I'll add request, select, cert.
Speak louder, please.
I'll add request, select, cert.
So what we are trying to do today is to crawl Pokédex by using two different languages. So you can see how Rust compared to other languages. So today we are doing a comparison between Python and Rust. So I'll be doing Python and he'll be doing Rust, the Rust version. So the objective of the script, the program is to go to this page. Pokédex. This one. Go to this page and go through every single Pokemon and then pull out the name, the type, then go to each individual Pokemon and we will extract data from this table. So to give you an idea of how the source of the document looks like, it looks like this. The important part is here. So each Pokemon is a card that looks like this, where the name and the type and the number is here. And when you go to each individual Pokemon, then each subset of metadata is actually a table, like this. It's a table somewhere here. So this is a table. So we are going to scrape the site and print out the Pokemon's data into JSON lines to the screen, standard output. So I'll be doing the Python version, and then Ivan will be doing the Rust version. So in the middle, if you have any question, just let us know. So we will try our best to answer. And then you will be able to see the difference between Python and Rust a little more clearly for those who are familiar to Python. Right? So let's start now. Okay. Okay, so we will be importing time because we try to be nice to not kill the server. So we will be importing JSON and import request. Then to read the HTML will be needing this practically this. So you can switch to.
So what I did just now is I'm just building stuff. I just added some packages here and then I start building, so I don't have to wait later, so I build first. And I need a few packages. I need request for web requesting to request the high level interface to web request, and select an interface like a selector to select HTML stuff, and then also cert derived for serialization and deserialization, which we will need later on. Okay, so now I build, and at the time I will continue to open up the doc.
You may want to show the toml file, the content couple toml.
I also need to edit a TML file. I need to add something like I need to add a special feature that cert requires, which is derive. Because 2018 edition, last time people need to use cert derive like this, but then after that, when 20 version edition arrived, so now they just put it as a feature. We don't need an additional crate for this already. So I'll just build again, and then I'll start working on it.
Back to my screen. So the rough equivalent to the cargo file just now is this file. Let's see. It looks somewhat like this.
Are you doing requirements of TXT? Not really. Okay.
Let's use PEMV.
I'm more familiar with this, but there are other solutions to this.
You can export to requirement.
Just pip freeze, PIP freeze, and then throw everything requirements.txt.
The good thing about this is I haven't used Python in a very long time, right? So yeah, I guess this is the newest. This one actually this is not the newest. It's actually an alternative because this one, if you notice, there's a Python version, and it actually integrates with PyM. So you look when you do this, it actually bootstrap the virtual env with the correct version number. I see.
But the adoption rate for this is much lower compared to
yeah, which is why I don't
compared to requirements.
There's some controversy.
Yeah, so now I need to build documentation. I just want to open some documentation. I need to build a documentation here.
So this is comparable to the.
Are you building documentation?
Yeah.
Okay.
The documentation is very useful. Once you build it, then you can use the documentation offline. So sometimes I can work like even offline. I just open up the browser in documentation, and then I just view the API documentation offline.
Right. It's a bit like Ruby building documentation as well.
Can I ask a question from the Golang Malaysia Telegram group?
Yeah.
There's this guy on the so PM the guy who says, I'm an Malaysia developer because I want to make web app. I don't understand why Rust is getting so popular. Why do you love it? How you compare to say Erlang?
Erlang, I know it's Erlang. How can I compare? Erlang.
Do you know Erlang?
I don't know.
If you don't know Erlang, how are you going to compare it?
Yeah.
Oh no. Right. Okay, anyway, yeah,
but I think Rust is different in the sense that Rust is safe.
Rust is safe, yeah.
Very few languages have that. Like I think Ada also has that, but the adoption rate is like so bad.
No one.
Yo, don't say that. Please don't say
Why can you that?
No, it's true. Ada has almost no adoption.
No, I didn't.
The usual Ivan come.
Ada.
The only major development I know of Ada is the Norwegian, the Scandinavian flight control system.
Yeah, NASA.
Across Finland. Is it NASA, the space shuttle?
It got into the wrong time, I guess.
The one
Somewhere between older one to the new one, but in between that there's a lot of other paradigms.
Yeah. So I feel like Ada is the original like mother of Golang actually. Yeah.
Oh, I was looking at this. So yeah, one
Yeah.
right now is crawl the Pokédex for all the monsters, and then for each of the individual monster, I do another request to the individual Pokemon entry, Pokédex entry. So I would need to get the name of the A tag of the Pokemon, which is a class of ent.a dash name. Okay. The anchor tag, which you can see. here.
So we are not using beautiful soup.
Sorry?
Not using beautiful soup.
You can, but I'm trying to keep this simple so that you can because the main thing that I want to showcase is the Rust version, not the Python version. So
So I just switch.
Why is it user building documentation?
Yeah.
No, I still haven't finished building the version. But yes, I want to reference, like, let's say sometimes when you don't know how to do stuff, you just reference this. It's very useful. Like there's a Rust cookbook which is like something almost official, but it's not official, and it's by the Rust Nursery. So I just like get it as cookbook how to script stuff.
Rust Nursery. Okay.
So there's this cookbook that you can see how stuff are done, but their examples are still old. They are still using the old version, which is Rust 2015.
So Rust versions are all based on year release.
Yeah, but they work backward compatible. No, there's only two versions.
Oh.
2015 and 2018. Right now.
Okay. So it's going the Microsoft Office route of every 3 years.
No, it's not every 3 years.
Okay.
They don't fix it to every 3 years, but it's just 2018 is the year, so they just.
Okay.
It's like 19. That's what they call, people call that marketing scheme.
Yeah.
Yeah, that's what they call.
So Rust as a marketing scheme versioning system. We're looking at Ivan's screen right now.
Is this Rust right now?
You're now in the documentation.
No, not yet. So
Okay.
that's why I reference here first.
Okay.
Sure, you did right.
Name class, what else?
It's okay.
Oh, so you don't need the external. Okay. I thought you need an external, right?
you need an extern when you import external libraries. So in this case, I'm actually not sure about what it's doing right now.
It doesn't need it.
Oh, because there's 2018 edition.
So 2018 has documents built in by default.
There are quite a number of what do you call it?
Yeah, 2018 you don't need to do that.
Wow, so 2018 doesn't need to import anything to understand HTML documents.
There are quite a number of quality of life changes in the 2018 edition. So there are quite a number of things that you don't need to write anymore in 2018 edition, such as some of the things that you write repetitively, like the extern here. And then there are also some of the lifetime thing that you might not see today that also you don't need to declare explicitly.
So you don't need to write extend anymore. You just use it and then it will find it.
In certain cases, most likely yes.
In certain cases, you
That's very scary.
In
in certain cases, most likely yes.
In certain cases, you still need extern, but just certain cases, not all the cases. Because they are planning to do everything, you don't need extern, but some place you still need.
Okay.
Not sure about now. I didn't keep track of the latest one, but I remember a lot of stuff originally need extern, then they don't need. Things on macros might still need it.
Kind of like lambda function in AWS where you can actually import something into packaging overlay that you got to have.
So I don't know what you're doing right now.
Make it.
This one? This one is already big.
Even your browser. Try to make it.
Okay.
What are you doing right now?
So what? I'm just referencing.
Implementing the documentation.
So I'm just referencing
Because the syntax is so hard, you have to
Okay.
cheat sheet.
So now.
Oh, debug is a new thing?
Yeah, it's a new thing.
Okay.
Yay, it's finished.
Do you need the.
Oh no, it's not.
Do you need to apply the type class of debug in order to use debug now? You still need the type class, right? Last time I remember you need the type class. I'm not sure what.
No, debug you don't need.
Okay.
You can even use it like you can even use it like I don't know what I'm doing.
try to switch your your tabs, try to switch them
Slower.
Okay. Debug. Wait a minute.
Doing it live is harder, right?
Live coding, you know.
I can just open up the previous one and see. I don't. I can.
Which is what I'm doing right now because I cannot remember. I'm terrible at remembering things.
What is unwrap?
Unwrap is let's say you have this data because request returns a result where whether if you will be successful or fail. So if unwrap is forcefully say, okay, I'm confirmed that this will work. If it doesn't, you'll panic. So panic Rust
means you fail.
You crash.
Yeah, there's two kind of error recovery in Rust. The first kind is the failable errors.
Okay.
The second one is the infailable errors.
Unfailable.
Yeah, unfailable errors. So it means
Unfailable means it will never fail, right?
yeah, unfailable errors means that you are sure that it won't expect. If it expect if this error happens, means that something is really wrong somewhere,
Okay, got it.
and you don't need to care about just fail the whole system or what.
So unwrap basically just says take the success condition.
Yes, just take that data. There's also a question mark, but then that one is something new, but I probably won't be discussing that here.
You can end your code by the question mark. Okay.
Yeah, if you end your code with question mark, it will do a unwrap, isn't it?
You mean end my?
If you put a question mark, what does that mean?
It
Same
means
as unwrap.
propagate the error to the previous function.
Oh yeah.
You mean the previous function in the scope, so the higher function, the parent function.
Yes,
Yes, the caller.
So it's like bubbling up, basically.
Yeah, it's bubbling up.
Yes.
So
no, it's
Raise.
like bubbling up the error.
Raise exception, throw or raise.
Throw right, yeah.
So if you notice when he use a question mark, the function itself has to return a result also.
Okay, maybe I'll show what unwrap does.
Then it will take forever.
Don't bother, just continue.
Okay, for example, let's say
He doesn't care.
No, I just show. Let's say you have this. Let's say this is almost the end of the function that returns some data here, but I don't write it. Let's say you have.
No, you do need a right. You do need a correct one. You just need pseudocode to show.
Yeah, I just show. Let's say you have this internal data. This is a result. Let's say data is a result, which can fail. Then this is a mesh statement. If it works, then you return data. If it doesn't work, then you return the same error.
Okay.
So this is essentially what, and with this you can write this as like this. So it means propagate.
Okay,
yeah, it's like
got it, okay.
Is that considered a macro? So
unwrap.
no, the question mark.
Question mark is not a macro, it's a syntactic sugar.
Yeah.
Correct.
You can recognize macro very clearly when a function name ends with exclamation mark.
Like a phrase, what you want.
Actually quite readable. Yeah, for someone who doesn't know Rust. Yeah.
So in that case, it's far less nice than Python.
I think that's what they're trying to demonstrate. Yeah.
No, I won't show the shorter line first. I'll show the longer line first, and then I
If
show
we
the
show
short
you
line.
the shorter line, it will
Then you don't
be
get
very
it.
not readable for you.
You're gonna show us the shorter line. What is the shorter line? But just one line, is it?
So debug, we return something like this. And the nice thing is, if debug, you can even assign something, and you can just debug halfway. Like let's say you can debug here.
Okay.
You can debug here.
Oh, it's a bar chart. Okay. Sorry, PHP getting in my way.
Yeah.
on the screen.
I think the video is lagging a little bit.
Oh, this is actually a snapshot of what happened.
So now I just need to find what? Forgot.
You're the one doing it, man.
Serious?
Hey,
Okay,
look.
so I copied some code from the Python one.
Oh, you win
Right.
Is that admitting that Python is more superior in like in terms of readability and being remembered?
No, because he wrote it out. So I just
I was gonna say the other one is community. Is there any more writing questions in the YouTube channel?
No. They have fun watching them.
Oh, okay.
oh, I need to do faster, so I just reference the bit.
Discussion is actually quite cool.
The Rust diagram.
Yeah.
Oh, so this is what I did. Okay, I just go.
About what? Oh, the game.
Oh, I need to find it.
You need to switch to your own.
Yeah, it's called Golang Malaysia featuring Rust.
Golang Malaysia featuring Rust.
Erlang and Haskell.
Erlang and Haskell. Everything is like kind of there. How do I get I think I have to search for Golang Malaysia.
Erlang Malaysia Facebook group.
Find for game.
Yeah. At the site.
But there's a Telegram link somewhere there as well.
So far, I've seen a lot of installing.
Yeah.
Oh, this is a Python one because I forgot to install this.
Right. It's okay, at least you install most of the stuff before coming here.
Yeah. Otherwise, we'll be waiting for things to install.
Right.
Okay, so now what I did is so I did something like this. So it is something like I just take each link, script the link, and I just show it out.
Find class. So class is coming from the predicate. Okay, I see.
It's a function.
And it's nothing.
But predicate, so it understands natively what class is for here.
No, it's actually
Library.
He actually imported that.
Okay,
When
so
you see
document lah.
yeah.
Document is where it comes from. I see. Okay.
Is there a naming convention like those capitalized stuff? You can have your function as a
Yeah, it is. Right. There's a lot of discussion going on about something else.
I'm done.
about GDK now.
Talking about Linux or something like that.
Not used.
It takes quite a long time to build, even for something quite small. Like Golang build time is faster.
Well, losing up some of the stuff like usable stuff.
Right.
Yeah. Because Rust has all these optional type and generic and stuff. So it's they'll be trying to improve the speed up. So it's actually much better. The thing about the Golang actually sacrifice this kind of stuff because there's less code generation during the compilation.
Right.
That's why it's very fast.
Right.
So it's
So you can be more verbose. So in Rust there's a lot more code.
Oh, I go to wrong link, no wonder, not fine.
some saying is Rust is like a child between C++ and Haskell, something like that.
So I written this.
So I don't write Haskell, so I don't know.
But I don't touch Haskell when I was in college.
Oh, okay.
I just written faster.
I think you're lagging much enough.
Because Alpine can do something that I want to do. I mean.
You know, he switched to Alpine while he was working.
Yeah, I know. Everybody knows about it.
Yeah. No, while he was working with us, so one day he comes in.
He switched to the Warwick as well. What is that?
One day he comes in, right? And we're asking to get, like, he's supposed to get a code right, and npm install does it work? Because they cannot build the CX.
The muscle agility, yeah. And
And also I heard he switched the keyboard layout to the wall.
Yeah, correct. Yeah.
My Chinese layout also different.
Oh, now
So you're still on correct, right? Or no?
Yes.
Yeah. He actually switched over to those and I asked him like, when you switch to this, wouldn't you have to adapt? And it's like, well, 23 days to get used to it.
Yeah, you switch to your own one because mine is done. It's already printing out for there.
Okay, then I just show what I did.
That's awesome. Basically, with Python, it's more code, but you get it working faster.
Yes, Rust you get it slower.
Python is not so throw it together.
With Rust, the end product will be incredibly fast, but it takes you longer to run.
Not necessarily.
Okay.
Mostly because of the speaker, I would say.
Okay. Are you going to then write the Rust code?
Try the model, please.
Such a shame, man.
You need to do more. So you get used to it.
When you're talking about Flutter.
Okay, there's one weird.
Group and what is the focus?
Like sometimes you get some errors, then you feel like, what is the error? You don't get it. Like let's say I forgot to put this.
Yeah.
Rust error mostly are helpful, but just like this.
Wait.
A lot, but sometimes
slower,
errors-
slower because people don't get to see.
sometimes error related to trade you don't get to see them. But like this, like oh you don't know what is this.
What is
At the end-
you try into?
Not implemented.
Why is request spelled wrongly?
You're not supposed to
No, I think that's the name of the request.
You're not supposed to pass in
Rust.
string.
It's spelled with a W because they
Correct.
Yeah. Okay. Yeah, see.
Right. Okay,
Slower. Slow down.
Engineers, common engineers.
Yeah, they are using this for diffuse trying to from request URL. So what they want is because what they want is you see request get.
It's like the Golang, right?
If you want request get right, they want something like the trade
Okay.
into URL, which into URL is polyfill try into. The thing is they accept string, but no, they accept str, but they don't accept string. So because
What's the difference between STR and
str is on the stack and string is on the heap.
Oh, okay.
Mainly is this different, but you can just use a string as a str.
It's more high because it's
Memory is the
Yeah.
version.
there's more.
Then what you do is you direct.
economics.
Like when you see this, let's say you don't know how to get str from string.
How do I know who implemented what?
Like this, you see the string,
Oh,
you just search for str. You see they say methods from deref target str. So means that this thing means that if you put a ampersand in front, they will make the
You need to switch back.
oh it's slow. But anyway, so when you see this ampersand, it means that it will convert that string as the str.
Right.
So they call this deref. Sometimes you get trade error, sometimes you don't understand. But at first you don't understand. Later on you will get it.
At first you don't understand.
oh,
Okay.
I like it.
So let's say this is the earlier version.
Oh, so debug it's not just a print, it's actually your assignment will still work,
Yes.
but you still print out stuff.
Yes.
Okay. Oh, okay. Oh, okay. It's very convenient.
Bulbous pocket exposure. What function request? Oh. Okay. Wrong URL again. So let's say Bubble saw this, right? So debug will show you some useful output as in this. So instead of getting so what debug will show you is because you do name equals to this. So debug will show you that this node text will be equal to this. You can also make the short debug version, but you need to use some environment variable that will make it short. But I forgot what is that. So usually I'll just use this long version. Last time before debug, what we do is we just do like print ln. You do this. Then this means that we can print the
anything that implements a debug.
Yes, anything that implements the debug trait. We should throw like the full version, but you don't need this because they implement the display trait. There's two traits for displaying. One is this, or you can put this as well, but it's out of scope. That is just like a pretty version of this. So this one is like short, the long version, debug trait, and then this one will be the display trait. We can use either, but now debug is here, so for debugging purposes, I just use this. It'll be faster. Then this version is like the non-rusty way. People say, like let's say why you want to build a string that's mutable, and then you assign it again. It's like you don't get what happened, right? What you can do is so what we do is, because doc find this is an iterator, like you can search from here.
Oh, this, okay, right. Oh, they look familiar.
Okay, let's say you find, right, they will return you a find structure, but you can see that find implements iterator. You can see this?
Okay.
And then
I would suggest you to finish the whole thing first. Let them see how it works.
Let's show us what you want to do.
Oh, okay.
Then show
Get
us
the program done, then you go back to it. Otherwise it will take 1 hour to complete.
Okay, sorry. Okay, never mind, I'll just get this first. So how this works is I just get the first thing, because here I just use the first one, right? Not exactly the first one. Here there's just only one item there. So you see that next return an option. So I know that I need to unwrap this. Option also have unwrap. So option means that it can be nothing or something. So unwrap is to get some value. This is how Rust handle the now values, the $1 billion mistakes, people call that. Okay, so what I do, I just take over.
Take over.
Okay, first.
I think it's only you now, because I think Siak finished his
It's a straightforward program to write.
Oh, not next.
So
Python is Python. Oh.
from the look of it, seems Python has won the usability.
So yeah, exactly. Python wins the usability, but definitely I think on speed in terms of actually running the stuff, I think Rust will win. So
Yeah. Okay, so I just copy it because I
no, we're just teasing you.
and for this situation, I don't know how much safety matters.
I think safety matters for stuff that are not running.
Alright.
Like servers and stuff, but for scripts, like even for scripts like cheat, I just throw away. I just have another small script to throw away the stuff that I don't need.
Yeah. use it.
No, do you have different version? I want to explain the different version later.
Okay. Oh, there's V3.
Oh, V3.
Right.
We're gonna be here until tomorrow.
Really good source from Microsoft.
You can use Git to do it, man.
Git?
Like just check out V3, then you can show.
Remember he did it last time?
Oh.
Yeah, he did so fast and nobody noticed what happened
Oh, okay.
in between.
Okay, this is a minimum version.
Minimum.
No, at least okay. I put
Does
some
it work?
stickers.
I feel like it's longer than Python as well.
Yeah, it's a bit longer.
Okay,
No, but the thing is, this is the version 1.
Okay.
The one that I'll say will be
So the last version will be 2 lines.
Okay, this is this I get this error because
I can 3 lines this in Python. I can 3 lines. Probably 2 lines, probably 2, but comfortably.
I can also 3 lines this in Rust. I just put everything with semicolon.
No, without semicolon.
No, I think you like, I guess, semicolon there.
But Rust also can extend at the end. You can just put one iterator and everything.
Fix your
problem.
fix
The
your
argument is you can do it in 3 lines. Yeah.
I'm just using you to get rated. Focus.
How many lines can you do it in 4 lines?
You should actually. Oh, a lot of lines.
Longer than this?
Longer than this because the HTML parsing is terrible.
I can probably do this in 2 lines.
But JavaScript sometimes sometimes the libraries are too flexible and then you don't know what to do. Like let's say you see this one, right? What they want is they say sometimes you to get this function descendant is that the compiler is telling you that this function doesn't exist without importing this. So you need to import that trait into this into scope first.
I thought you imported predicate into it.
No, I just added before I compile. Now I compile again.
we have to do more. I think you have to do more of this.
Yeah, so now they just show all this stuff.
Yeah. All this stuff.
Maybe we don't have time to even have a glimpse of what happened.
Yeah, right? So she went there.
Huh?
When you switch to a screens,
Okay.
stop for a few seconds.
Stop for a few more seconds.
Try to spend more in explaining than switching like stuff. Even though it's smoky, it's fine.
Just now what I do is just for debugging, I just print all the rows out. Just like that. Because that's why it has a lot of stuff. So I run.
When you have the same when you have the same code running twice, it's like the same like.
Yeah, because I copied the wrong thing.
And Rust is okay with that, like.
No, huh?
Okay.
Which one? No, Rust is okay with shadowing.
We call
It's
that
very-
shadowing if you
Yeah.
do the declaration
Multiple times. Okay.
with the same name. Okay. Instead of overriding it, we call it shadowing. It's treated as a new thing.
As a new thing. Meaning it's a new thing in Rust.
It overrides the previous.
I see, okay.
Completely.
Got it.
Because of the life cycle thing.
And
allows it to do it.
and whenever the time comes to drop the reference, you drop the latest one first, and go back to the previous one, and drop the previous one.
Rust also comes with a format.
It's like extra layer scoping.
Yeah, but okay, I explain. Now when I'm running, I explain why we need this. So let's say sometimes you have a data, then equals to a like hello world. But
You need to explain
I-
why it's okay.
okay is result. Like
I kind of figured that from okay and error just now when you do the match.
yeah.
Yeah.
So okay and
What is sum?
Sum is
okay, there's
yeah,
explain two basic data type. The data structure,
Okay.
enum.
Is there a name for it?
it's an option.
It's a function.
Continue.
So
It's an
we have
option.
option.
Okay.
Or maybe I should just show this.
Option is an enum basically.
It's an enough.
Okay.
Yeah.
Can be both numeric or string, usual kind of enum.
I can wrap different kind of data depending on what you declare.
I think some of you guys heard of it, the terminology of algebraic data type.
So
It's really a
option. Okay, I show the official definition is here. It's an enum that have none and some. So if you have a data that can be nullable, you just use this.
Okay.
Every time you just put a sum in front, like sum.
So sum has to have.
Option has to be either a sum or a none.
Can it be a combination of them?
No, it must be one of them.
Okay.
One is considered sum, I think, right?
It can be some or none, but it cannot be neither or cannot be either.
Okay, let's say I have an enum, right? Okay, so imagine enum as like a single choice question, right? So I have ABC and I also have none. Is that possible? Or no, it has to always be either ABC or it can be none.
It cannot be both at the same time. It should be either one.
It's mutually exclusive.
It's mutually exclusive.
So
yes.
none is possible, but it cannot be none and some at the same time.
Yeah, this is one of the reasons like how Rust becomes it is because in matching, just now you saw the mesh, right? Like mesh, right? Mesh data. If I only put if I only extract the inner data out and then I print it out, but I just ignore the error. I just put it like this. What it will happen is it will throw an error saying that what will happen here is that it will throw an error and tell you that this is not valid because you need to mesh every data inside.
Okay.
Or you can use wildcard to mesh everything.
Okay.
But this is one of the reasons how it becomes like you know that whether you have covered all the possible issues.
Right.
That's why sometimes it's longer. You see that it's longer, but then it covers all the cases, edge cases for you. And you have option, and you have result. Result is different in where it contains two variants, okay and error. Okay can be different type from error. Error can be, this one is like this is generic in Rust. So you can contain a normal type, or you can contain some kind of error. It can be a string or something like that. Yeah, so this is the result. Usually you use this result to represent something that can fail and have some error code or some kind of error. So and why we need like to shadow this? Let's say sometimes you want to modify the data. You want to like I want to make this data. I just want to unwrap. If you want to do this without shadowing, you need to do that something like this, right? Then so why not just like overwrite this instead?
Also, the reason why he does shadowing here is because the first line of the assignment of data is one type, the next line is another type. And so when you do shadowing, it can change the data type also.
And that's okay.
That's okay. When you do shadowing.
Okay. When you shadow, the old one will be like gone, and it will be a new data type already. So the data type will change as well.
But the only requirement is that you need to put the let keyword in front.
Got it.
Yeah. This will be a full assignment.
Yeah. Right. So if you omit let, then it will throw it.
It will throw you.
Oh, it's running. It's running already. So now the output is. Oh, I run too much. I run too much.
You run too much.
The thing right now, what I did is I just print it out.
Okay.
There's no serialization done or nothing special done here. So okay, now I'll explain how to improve this. You see this pretty much you understand, right? This one is to find the
when you ask me to wait for a while.
Yeah, is there any question first? Any questions?
There are 4 people watching on YouTube.
Yeah, how to know if they ask questions?
I know, I'm talking with them.
Oh.
Just talk to the camera. Alright.
Why do you repeat those next twice then?
Yes, later I'll show. That's the version 1. Because sometimes
because
people don't get
it's
it.
an iterator, the nodes is an iterator. It's
So why do you repeat it twice?
This one? Because I
to
need to
get the
skip
next
two items.
table row.
Okay, so you have so it's actually because of the structure of the HTML.
Yeah.
You have to jump.
I need to jump twice.
Okay.
Later I'll explain on this, how to, because at first when you're new, you doesn't know a lot of stuff they provide in Rust. So
I'm familiar with generators from JavaScript. So this
Because in Rust, there's a very heavy influence of functional programming in there. So if a program can be written in this way, it can be further be written into something that doesn't look like this later. Yeah.
Okay.
okay, let's say
Yeah, can continue.
do you understand this part? Where you want to find some data, and basically you in Python is
You don't need the comparison, you just explain it.
types. You have the types.
What are you looking for? Type up there.
No, just explain what you're trying to.
Okay, I explain it.
Okay.
I'm training for you.
So this one basically you create a type, a vector. A vector is something like an array except that it's in a heap. There's array and vector in Rust. Array is the one on the stack. You need to provide the size compile time at the compile time. And for vector, you can resize it dynamically. So it needs to be mutable here. If you remove the mutable, you see some errors. Because you want to mutate this. So you want to add something to that type. If it's not mutable, because Rust is immutable by default, they don't want you to like just put everything mutable, then you cannot throw data in. This will be similar. You see this pattern similar in how people do in Python. Let's say Python is like this, and then like you say something like
exactly like the one I did. You can switch to the
yeah, exactly how
For master increase.
the first few lines up there, the for type, the for loop.
exactly like how it did. Like, but people could do this in Python. Like, if they know this is similar to the one in Rust. If they have another way to do this is
you can do this comprehension.
it's like risk comprehension.
Oh, he wants to do now. Okay, list comprehension.
Or map.
Yeah, so in Rust you can also do something like that.
Okay.
So
but it's not like Python risk comprehension. So
because there's no this comprehension in
how is
Rust,
it?
so I think he wants to show this instead.
Yeah, so Rust have something like a collect.
Like map.
Collect is called when you want to actually evaluate the result.
Yeah,
so by default everything is just definition. It's very lazy. It's a lazy evaluation. So the value will only be compiled when you call a collect.
Yeah, collect is a function in Rust iterator. So when you collect, it can return B. Oh, but what is B? Then you see, oh, this is from iterator. So you see, okay, collect can from iterator. But you notice that I think Java also have collect, right? Java. But this thing is
It's wrong words.
huh?
You just put out languages that you expect to.
Yeah, you should ask that. Who here writes Java?
So,
Okay,
let me see, give an example.
how is collect useful here is because collect doesn't just collect it into a vector or collect it into a hash map.
Basically, it resolves the.
can you go back to one page, previous page? No, this one, the previous one. Down there. Does it mean that
if I don't do collect, can I still use the map result? It's an iterator of that thing.
No,
It's a method for the iterator. So
Yeah.
you need to, if you want the value, you need to call collect to evaluate the iterator.
But you collect everything, right?
But I can
No,
also
the
call
collect
next
here
instead, right?
collects the result according what you declare. So in that case,
Yeah, but yeah, it iterates over the whole, iterates
it expects
everything.
and vector.
So instead, so basically instead, so I get out the whole array, or I can do dot next to get one by one, but basically, okay, got it.
No, but this is similar to what you did
It
just now.
depends on what you declare, what you expect from the collect.
Sure.
So you can also expect a single value.
Okay.
You can run the reduce also by using collect.
No, but collect will iterate through the whole iterator. But collect here, they iterate through the whole iterator and give you what type you want.
Okay.
So let's say collect is very powerful here in the terms that not because it expects from iterator. So from iterator can be a vector or can be a vector of values.
Definition just now.
Hmm?
Just the collect definition.
From iterator,
Yeah. Oh.
like multiple items have implement this from iterator. So let's say you want it to be, you can make it like this.
Wait, it's not showing.
Oh. Crash. Okay. Oh.
Okay, so what this does is you can collect this into a vector
No idea.
of this is, you know what it is, but you lazy to type. So because Rust have type inference,
Okay.
so they infer that this is the value. What's the value? This should be a text.
But there should be always a default type for certain things like integer.
No, it's not a default. It's like the
It infers.
Infers as a because the issue I have with Golang is sometimes it was inferred to int32.
no, you cannot convert. It will be the default. Yeah, it will be string.
Or you mean the data type?
Yeah.
If you want to convert, you cannot convert from here.
Or that's all preferred data type for number.
Yeah.
So, yeah.
So if you need, then you put it in, or else you
Yeah,
just follow a default. Let's say I have 1, 2, 3, 4, right? You always, if you put it there, it infers to what? Let's say 1, 2, 3, 4.
It's 64 if I remember.
No, it infers to the type depending on the result or depending on the input.
For number, it prefer I
Let's say I serialize it.
query, isn't it?
Let's say I serialize it actually from text like JSON. So there must be always a default preference for like something like.
It's not a default preference because by default it is string. So they are according to the default value. Let's say you see this.
He's asking.
I think
He's asking if there's a number by default, what kind of data type that is going to be stored in.
Yeah,
if you don't explicitly put in the data type. So by default, it should be i64, i32.
Okay.
Depending on the CPU architecture that you are in.
Okay. So normally we 64.
Yeah, most of the 64 if I remember correctly. Let me see that.
What?
You continue. I understand already. I remember there's a shorthand for lambda, right?
Yes. Yeah, this one is they don't call this lambda, they call this closure. It's different from a lambda in the sense that
no closure is lambda also, right?
Yeah, but they define by their definition, they explain like how it captures the inner variable.
Okay.
For example, here I need to map, right? So other than this, you could do it other way, is that you can make it like here. You can make this here.
Oh, that's okay. Or outside.
Yeah, you can that one they call just now that one.
But collect will give you, if let's say something is wrong in between. So collect will give you error or will give you none.
If it doesn't match it cannot fulfill your requirement, then it will return an error. Okay. Yeah. So to answer your question just now,
collect won't return
numbers are
error.
always I32 if you are not
Collect won't return an error.
Collect will return an error.
Yeah. Collect will return item. The item that is
Empty
inner.
item.
This is the inner
yeah,
item.
but if it cannot return the item,
No,
then
but
it
you
doesn't
have a
count.
result. You see a result E and E,
Exactly.
right? E is error, right?
Where?
Down there in the type definition.
No, because this
Result
one.
takes two different data type. One is the actual return value of the intended.
This is
type,
not.
and E is the type of the error.
This means that it's an item. That what they say here is if the collection of results.
So the item itself will be a result.
Type E.
No.
Type
Okay.
E.
Only
Then
if.
your error must be in type E.
Okay.
No, here that means that this collect is have an item of this.
Yeah, I understand now.
But this collect have an item of string. So when you collect it, it will become string itself.
Okay.
So you just collect.
So means that if you put in just now the result like that, then if it fails, then you get an error object in a collection of error object inside. Okay.
It can be collected into like different types as well. You can collect it into tuples, or you can collect it into array, or sometimes you can collect it into other stuff, not just vector. So collect is a general method. Yeah, this is how to improve it. Let me check the versions. Yeah, I forgot a few. Okay, so this one, double next. What can we do? Like, why are there like two next? So I don't want two next. What I do instead, I can just skip. I just skip two values. It's the same as skipping two next.
Very functional.
Yeah, you can write a very functional code with Rust.
Yeah.
There's even a more functional way. I can
More.
I can make this whole thing functional.
Okay.
And it seems to be the preferred way to write code that involves operators also.
Yeah.
Okay, Ashray, just now you say that there's two next, right?
Yeah.
Now
So
I just
You're just
skip.
doing the math instead.
No, I just skip.
But you skip by 2 also.
Yeah, but this one is like show how is it like functional. What I mean like
Okay.
sometimes they call it functional because like this you can just skip two values.
Right.
And
it's not functional. It's the method you provide is very functional.
yeah.
Guys, sorry, I got a problem first. Julie is going to be here.
Okay.
Okay. Yeah. There's not much else if you guys want to continue conversation.
Okay. Thank you.
We accept that.
Okay.
Alright, thank you.
Thank you very much.
Thank you. Yeah.
Okay, so after this we have Sir Jason.
Yeah, 1 more hour.
This is supposed to be a 1 hour thing at most. Why are you taking this so long?
You have to practice more, Ivan. You have to live stream more. Do you live stream?
No,
You have to live stream more. You have internet at home?
have until 12.
Oh. Okay.
So there's a JSON macro provided by the macro crate. So you can just write something like macro here. So what you do is you just write the name. Where's species?
This is pretty fine.
Right. Expected identifier. Oh. Yeah, but the issue with I noticed that the issue with this this thing, right, is that this macro they don't keep the position. Like this macro is provided by the cert JSON. Cert JSON is like a very nice serialization deserialization framework. This is to just create a JSON value. And what we are going to do, how we are going to improve this is that we can use like because this one they don't give you the original position, like you can see here. Then what you can do is you create a
is normal, right?
No, that's not normal.
You mean the order of the.
Okay, now I'm going to create a structure Pokemon.
Swap will be swap will be positional, but that's now I think it's a hash map, right? Hash map is never positional.
Oh, okay.
I think it's a different type. It's not because of this. It's not because the internal memory representation is actually 0, 1, 2, 3 like that.
Okay, so now I define a structure here, and I give it a serialized device.
Yeah.
What it does here is
You're not comparing apple to apple now.
what it does here is that it will they will create a method serializer for this. They will create a implementation for serializer for this structure. So essentially this is like a code generation thing where they will do something like implicit. And then they do a bunch of stuff here.
A bunch of stuff.
Yes. And then they generate.
All the usual.
And then they generate based on this. Okay, so now based on the output, how do you want to make this into a Rust type?
Yeah.
So what I'll do is I just create a
Even you
Pokemon.
have a predefined struct, you want it to put the string into a struct. Or
So you just no, it's not predefined. You need to define it here. Name type species
you
type.
need to type all this out.
Wait. Yeah, you need to type it out because
Even though you are not giving it a value.
oh no, because
These are values.
this okay sorry.
Oh,
this,
the value from above.
Yeah.
So
Yeah.
it's similar to ESX kind of thing.
Yes, this means that something like this.
Oh, okay.
So essentially,
okay.
I don't need to put it in.
Oh, okay.
If the variable name is the same and the type is the same.
Oh, okay.
So what I'll do instead is I'll just serialize this Pokemon into a string. So I'll just do Pokemon yeah, I'll just toString serialize toString. Yeah, I need to borrow here because cert expect them to be borrowed. It's a concept out of scope for this meetup. Yeah, so now this essentially Pokemon, what it does here is this one, you create like a serialized implementation to show Pokemon like can be serialized into.
It's a struct that implements the serialized.
Yes, implement the serializer.
Serialize is the trait, right? That's what you call it.
Serialize is a trait. There's two traits. it's a bit confusing here. There's serializer and serialize.
Okay.
One is a data type and one is a data structure.
So the derive fill in the blanks for the struct to implement the serialize
Yes.
string.
So there's also deserialize, but I'm not using it here.
Doesn't know do it.
There's also deserialize, but I'm not using it here.
Okay.
Deserialize is like when you have a string and you want to convert that string back to a Rust structure, then you can use deserialize. And serialize is when you have a Rust structure, you want to serialize it into a string, or yeah, you can use.
It's always a string, something. Sometimes. I mean,
Sometimes it's bytes. Sometimes you need to use bytes. Sometimes you need to serialize into writer. Yeah, and the nice thing about serialize in Rust is that you can just serialize to CBOR by just changing this. If you want to change to CBOR format, you add CBOR crate and just use this.
What's CBOR?
His favorite format.
Some binary format. Common what is it? Common binary format. Forgot.
Why don't you use protobuf?
No, protobuf. Oh yeah, there's a few things. Cert right now only supports a few like data format. No protobuf or Captain Proto here. So most of these, right, they have the similar API or same API, you can say.
There's what message pack, right?
Go back to the.
Yes, it supports message pack. I go back already. Okay, so there will you can just change to different data format just like this.
Why do you like SIBO?
If you don't like, then you can change it to something else, no? Like YAML.
Ask question like leaders.
No, like YAML. I can change it to YAML.
Why do you assume that I like YAML?
Then what do you like?
I don't know what I like. You tell me.
Okay, so I say you like SIBO.
He still has a topic to talk about.
Yeah.
You have less than 1 hour. Can you finish it in 1 hour?
Yeah, I'll try. Yeah, so any questions? Did I get any questions?
Not at the moment, but I have to leave. I have to leave. There's something wrong with it. It's something
Okay.
But I'll continue watching on my video. I'm still on that.
So this will be. So it's done.
You asking me what? Wow.
Yeah.
Okay, bye bye.
Thanks, yeah. Bye. Are you done?
Oh, you have another for parser, right? Okay.
Yes, okay, this is about parsers. Who done parsers here? So whoever done any parsers? I wonder just anyone done any parsers? You done parsers? Okay, just asking. What is parser? Okay, I need to do. Yeah, what is?
No, put it here on the neck.
Yeah, like what is parsing? Yeah. Parsing. Okay, I'll explain. Parsing is just not limited to text parsing. Okay, like just now what I say, SIBO, you like the format that you like, SIBO. Okay, so it's not just limited to text parsing. It can be binary parsing like CBOR, or you can parse programming language, which most programming language they will have what? Alexa and tokenizer, like, and parsing happens like somewhere in between. So you can also pass like network protocol, like I think I need to charge. So you can also pass like, let's say PCAP, you all know what is PCAP? You can also pass PCAP or IRC formats. You can also pass like all the text just now that I mentioned, or anything data that is structured, you can pass if you have like a structure on how the data works. So today I will be explaining like how you do parsing in Rust and what kind of different parsing style that you will see like commonly here in Rust, how extraction works. So I'll just be showing something simple without like main explanation here. So okay, first start of parsing, hand roll. You just write the parsing from scratch. So you write the manual parser, it will be something like this, or it will not be something like this. This is one of the type, because it's hand roll, so you can write it however you want. So you will see that all kinds of stuff like from A to Z, you'll see like A to Z. You'll see any different kind of stuff, how parsing will work. So in this parsing example, they leverage like Rust parsing. Let's say they match the input. It's common that in parsing, right? It'll be common to see people using like array. This is array in Rust, like unsigned integer. So they pass it in bytes rather than string. You also see like some people passing in string. So what it does is you have a tokens and you keep looping in the token. So you match the others. So you match the first few items and then you get the others here. And then you match like what is passed here, what is passed, and then if not, you just handle errors. So how like hand roll parsing works, like you can have full control, and it can be very optimized, like it's very fast or very slow, depends on how you write it. So for example, you can see like search JSON is also hand rolled, like SIMD JSON, like way faster than search JSON, except lesser people that use that. But one thing to note that if you do manual parsing, it can be tedious and diverse. Like you need to reinvent the view that everybody do. Sometimes you just don't want to do like manual parsing. What can you do? Now, like manual parsing or hand roll parsing is like on the extreme side to do stuff manually. Okay, and then on the extreme side, okay, and then if you want to do something so cool, but you don't want to write all the parser code, then you have parsing expression grammar. So you just write this once, and then okay, this will look something like this. I taken this from PES, a library called PES. So you write something beautiful as compared to writing everything hand rolled. Something like this, you can define that like something as pseudocode, like a domain specific language. So this is something minimal I took from a part for parsing JSON using this. So some functions you will see how this works is that they also give the structure of parser, and they take the grammar. Like just now, the file that you see is json.pass, and then you pass, and here I'll show some functions how you pass the value. So some functions will be like this. You just iterate through all the tokens that is passed, and just use it something like this. That you write like a lot lesser Rust code, but you still need to write some domain specific language which you need to learn as well. What about this? Okay, you can see that it's like very expressive and very beautiful, but sometimes it's hard to configure. It's like way slower than the native parser. Like later I'll explain about this norm, and it will be a lot slower than original version. And this one, using this type of parsing is very hard to optimize for speed. Okay, next. So first I talk about manual parsing, hand roll parser, and then I talk about like using something like very expressive. You just write the language and then they will automatically pass that into the stuff that you want, and then you can just use all the parser stuff. Next is parser combinators. This is something I find like very big special, like combinators. What is combinatorics? And then what is functors? Huh?
It's logic programming. Logic programming. So it's similar to logic gates and stuff. They call it combinators. If you do electronics, you see this kind of terminology as well.
Oh, okay. So you see so you see functors in Haskell maybe a lot, or I don't remember. Okay, so basically what they do is they just combine functions to pass Rust code. No, to pass code. Pass stuff. Yeah, basically they're just combining functions to achieve stuff. So different types of parsing. There's like trait based, function based, and macro based. There's also one more, but I forgot what is that. The most used method to parse is like using function based and macro based. This is the most famous library. Currently they use, okay, why I put here is because this is their tagline. They just call eating data byte by byte norm. And macro based is they just write a bunch of macros and you just use those macros, and it can be similar to DSL. It's very powerful and fast because norm is like almost as fast as the native hand roll parser that you can roll, except it's a bit slower sometimes, and it has like a very steep learning curve at first when you get into parser combinatorics, but later on it'll be easier, and also it'll be harder to debug because it's using macros. So an example is here. This is based on an example you can see in norm, the library, and this library, inside their main file, they will show an example called using macros. You see that they have name and do pass. This is to pass a hex color code. Then you will see that they pass something like this. I'm missing something, but then this is like the general idea how they pass stuff. Okay, so next, function based. Like, I'm not sure why, but norm is switching towards function based approach. In norm 5, they are still developing like norm 5, and there's also POM, not so famous. There's also combined. There's a lot of others implemented using function based. So norm 5, I have no comments because it's not out yet. Okay, so this is something like how norm 5 will look like. So what it does is, let's say this is a JSON parsing function. What it does is that it still uses some macros right now, but the main parsing will be a function. It will be something like this, where you just, this one is to identify the value for the parsing. Okay, so norm 5 I discussed. Now there's combine. Combine is yet another parsing library. It's you can say easier to learn based on their site. That's what they say that for themselves, compared to macro based library, but it's slower than norm. And this is one of the example for parsing in combine. You will see that they put a lot of these functions, and then they have something like this. This is to pass a TOML file. An example to pass a property in TOML. So you can see that they combine this function and like this token, so you can get the stuff out using just functions. Yeah, and then now is the reference. These two links are very useful. You can see the first one is the first one will be they'll show like a tutorial, step-by-step guide on how to write your own parser combinatrix. It's like a hello world to parser combinatrix, how you combine the functions and how parser combinatrix works is that they just show from nothing, they build some functions that pass and then combine functions together, and at the end they have some outputs that pass XML, a simple XML. The second one is they do a basic presentation, but in this presentation they show the comparison between non combine and pass, like just now what I discussed as well. Pass is the one that I showed for the pack. This one is pass. Yeah, so the first link is very helpful, and the second link is just showing the combination. They also show some benchmarks for the same thing that they want to pass. Any questions? Maybe I think you need to I need to show some examples on how parser combinatrix looks like.
Sometimes I write from scratch. Sometimes in libraries and stuff, I think already you can see a lot of the parser is also called parser.
Okay, this one is I actually wrote from the link that I showed. Oh, I just showed the original tutorial because like mainly based on that. Okay, maybe I'll discuss. I'll discuss like a few issues faced. Pretty much I hit the limit of type in Rust. So when you combine too much function, there's like so many types going around. So and then I hit the limit that you need to put something like type size something like that, and then you need to, the compiler will warn you about this error, so you need to like increase the number of types, and then you notice that the compilation time will go up a lot. It's like 1 minute box. This will be a bit slower, a little bit sacrifice in performance, but they allow you to avoid the errors. Box is something like a wrapper to something like a wrapper or pointer. In this case, they point to a dynamic how to say dynamic trait. This DYN, this is a trait. So they say this box is something that contains a parser. So this one make it fast to compile, but a bit slower, but you won't notice the performance difference right now unless you benchmark it. This is what I noticed during the encoding. You hit the type limit. What they do here is also they write some tests. Let me see a very basic. Okay, a very basic example can be seen here, like Yeah, okay, I just show this. What, like, you want the left item of, this is a function, when you want the left item of a parser and the right item of a parser, you just get the pair and then you get the left item, and the pair is something like this. So you run the first parser and then you run the second parser and you return both the result. So this using a pair. And where you get this path from, this is a trait that they're specified for this parser to have. Let's say this parser, all this implements a parser. Like you can see, like the parser, we have this parser, and the parser you have a function. So for this, it means that for all the functions that return a pass result, you can see here, f is all the functions that will return a pass result, and then you add a function to them. So it's like something like auto implementation. Okay, I repeat, just for all the functions that implements this pass result, they will take the function self and then they'll run it on input if you run pass. You understand? Okay.
I think it's fine. I feel like you can use other programming language to do parser as well. So what is the advantage of using one?
So in this case, you are able to define a trait.
I can understand by web engineer from my SQL knowledge.
The benefits here is like you keep it safe and it's fast. That's the main benefit.
What if I'm not concerned about safety?
Then you can just write C.
It can be actually it's actually a very wrong result. So you can show us a very small example of what is a combinator and how to use it in parsing. So basically you write a lot of small things that process only certain small parts, then you get them together. So basically the complexity of writing the parser is normally when we do it, it's like a state machine, right? You check, yes, then you proceed, then you proceed. That's the very fast one. The very fast parser works on tokenizing, right? Every byte, and then you do. But the thing with this is it allows you to do something like feature filter, something like that. So everything actually just has its own. Like I want to, for this function, I'm gonna check whether there's a like value or follow or something, that function that you want it to be. Like let's say a certain declaration of types and things. So I don't know how to explain it properly. It's actually there should be, I think it should be simpler to show a simple combinator function and how do you do a simple parsing, something like that.
Yeah, I think you.
It's very hard to visualize that.
Yeah. No, because you should follow. I think you should follow the tutorial. It's like quite long, but you notice like at the end, wow, I can do this with. Okay, let's say I've implemented.
I'm not a programmer or developer. So do you guys use Rust in your day-to-day work?
No. No. I don't use it day to day, but I use it.
But you use it in your daily work, right?
Daily, but not in my work.
Oh, yeah. But so those kind of jobs, like what are the reasons why they choose Rust over?
They use Rust mainly because they want to write something that is safe. That is the main thing that they are marketing.
Or something that can be parallelized very easily.
Compiler is very strict. So it's supposed to eliminate issues, programming issues.
Yeah, so it's like a teacher to guide you to write a better code. Let's say you write Python, people can write, or C, you can write all different kinds of style, but sometimes you get a lot of runtime errors, or unknown errors, and then you need to change the whole program to fix your code.
No. It's actually basically, undefined behavior. Issues like sometimes certain logic that you do or certain things you didn't, like let's say you did see before, like something like as simple as you initiate a variable without giving it a default value. So you just when you call that value, of course, when you first initiate it without copying it into that memory space, you actually get whatever value that is on that memory space.
Yeah, and then get some rubbish, some random
Rubbish
numbers.
or something like that. Then these are the what you call it, inconsistency in the program that caused by some of the programming mistakes.
Yeah, but in Rust you don't get inconsistency. So you
still will get if you are not careful, but the compiler does a lot of job in making sure you write correct programs because it's very strict and on at the same time it's being very helpful. So whenever it spots mistakes, common mistakes, then it will show you what could be wrong, then it will show you how to fix it. Then so to certain people it might seem very like not kind because Rust complains about everything, but sooner or later you'll find it helpful because yeah, because it shows you how to fix it and it avoids prevents you from making obvious mistakes.
As your program size grows, like when you have big programs, then you have issues of sometimes making sure that your changes doesn't screw up the whole thing by introducing some stuff that you don't know what you're putting in as well.
So the learning curve is steeper, right?
It's
harder.
not really that steeper, but if you run, it depends on how much, the problem that you have. If you have a complex program, then yeah, the learning.
I think there's a lot of new paradigms right there, that's why people say it's deep, right?
Yeah, because there's something new in Rust. Like let's say you have ownership, you have ownerships and lifetimes, which you don't usually see in other languages.
Ownership is a new one.
No, you say it's only happened in the last time,
It happens in other languages.
But very rare.
Yeah. It's not enforced. It's something that's used by practiced commonly by C++ programmer, which why do they call it III?
Is it common? I don't think it's common.
Very common.
Oh.
III is very common.
Because the reason I start to look back at Rust again is because just now I mentioned that in my job I came to a position they written using Rust. So for some reason we need to somehow modify it. That's why I just can't.
Huh? What kind of application written using Rust?
I'm doing DevOps stuff, the survey graphic. So yeah, we are using the
say goodbye.
Hardware.
Say goodbye.
Say
goodbye. Say bye bye.
The keep the
Bye bye.
Bye bye.
No, to the screen.